Okay, so here is the solutions to the second part of this test. This is the part that you can use your calculator on. Okay, so this one we're going to convert this to degrees, minutes, and seconds. So first of all, you have 328 degrees. I've already given you the degree part. So we need to take the 0.56. Now what we're going to do is we're going to multiply that by 60. Okay, and when I do that, I'm going to just get my calculator set up here. Okay, so if I take 0.56 times 60, that's going to give 33.6. All right, so what that means is we have 33.6. The 33 becomes the minutes. Okay, and then this, you can take that and multiply that by 60. So that gives 36, and then that becomes the seconds, like that. So that's how you put that together. Okay, now there's a real quick way you can also do this if you want to. You can do this on your calculator like this if you want to. You can just put in the 328.56, and then you can go, I think it's to the angle command, so you can go second angle, and then go down to this DMS key like this, and then it gives you the same answer. So I don't care which way you do it, either way is acceptable. Okay, let's see, the next problem, we can do this like this. So we have 135 degrees. We know that 30 minutes is out of 60, so that's 30/60 of a degree, plus 48 3600ths of a degree. So there's 3600 seconds that make up a degree. So one thing that you could do is you could just put this in your calculator, and one quick step like this, 135 plus 30 divided, what am I doing? Okay, let's try that. 135 plus, this thing's not working. There we go. 135 plus 30 out of 60. And then plus 48 out of 3600. Just put it in like that. And then that'll give a solution to the problem. So that's 135, and we want to round this to 2 decimals, so we'd just say 135. 0.51 degrees, I think is what that said. Okay. All right, so that would be an answer to the problem. You can do it that way. You can also do this on a calculator like this. To me, it takes more time. You go 135, then you go to second angle, and then get the degree to come out. So press enter. Then you put in the 30 minutes. Okay, so you can go like this. Get this to come out. And then you can put in the 48 seconds. Now the 48 seconds, the seconds is above the plus sign, so you go alpha plus. And you put that in, and it gives you 135.51. So you can do that problem either way you want to. Okay, let's see. Let's take a look at this number 3 next here. And this is an application of, I think, basically S equals R theta. So I'm going to basically just draw out a circle on this. So this is going to represent planet Earth. And what it's given on here is we have 2 cities with different latitudes. So if we look at one of these latitude lines is 80 degrees 45 minutes north. The other one is 30 degrees 54 minutes north, like this. Okay, and then we're trying to find the distance between these 2 cities. So ultimately, what we need to do is we formulate this kind of thing like this. So we need to figure out what that angle is. And then the radius, they'll give you the radius of the Earth is 30, let's see, that's 3,960 miles, like that. Okay. And then ultimately what we're going to do is we're going to find that S. So remember what we learned is we have, that's an arc length. So ultimately we have to use the formula S is equal to R theta. Okay. So the first big part of this problem is to find this angle theta. So that's going to be the difference between these two angles. So what you need to do is you need to take 80 degrees, 45 minutes, and subtract off 30 degrees, 54 minutes, like that. And then you can do this by regrouping. You can do this on your calculator also. So what I'm going to do is change that to 79 degrees. So I add 60 to the 45. So 60 plus 45 ends up giving 105 minutes, like that. Okay, so I have not changed the problem. I just took away a degree and added 60 minutes onto that. So now if I take this and do the arithmetic on this, 5 minus 4 is 1, 10 minus 5 is 1. So that is 51 minutes. And then this would be 49 degrees, like this. Okay, now whenever you use this angle, okay, when you're using this formula, theta has to be in radians. So you got to remember this formula doesn't make any sense unless you're in radians. So what we'd need to do is we'd need to take 49 degrees 51 minutes, and we need to multiply that by pi over 180. And since we're allowed to use our calculator, I'm just going to display my calculator, and we're going to crunch that out this way. So I'm going to do this like this in parentheses. I'm going to say 49 plus 51 sixtieths, like that. Then I'm going to multiply by using the pi key over 180. And then we'll round this off to maybe like 2 decimals. So let's use 0.87. So we're going to end up using on this 0.87 radians is what we get for that angle. Okay. Now going back to finish the problem up, we know that S is equal to R theta. So the radius I gave you in this problem is 3,960 miles. Okay, theta was 0.87 radians. Okay, now I can multiply those two things together to get my approximate answer. Okay, so let's do that. 3,960 times 0.87 is going to give 3,445. All right, so we'll just put that in 3,000. I already forgot what it said. 3,445. Okay, you can put the 0.2 on there too if you want to, like that. So that would be the solution to that problem then. Okay, S equals R theta. The important thing is theta must be in radians. Okay. All right, moving on. Now this number 4, what I'm going to look at is this one. I'm basically giving you the CD player passes through 24.2 radians in 3.3 seconds. Now see, that is an angular velocity because the units for angular velocity are radians per second. So omega stands for the angular velocity. So we're going to say 24.2 radians. And then out of 3.3 seconds. Okay, like that. Now let's just take our calculator and let's go ahead and crunch that out. So if I take 24.2 divided by 3.3, it's going to give 7.33. So let's just round that off to 7.33 radians per second. Okay, so that's a piece of information that we have now as we have omega. Okay, so it's telling you the radius R is 6 feet in this circle, this CD player. And what you're going to do is you're going to find the linear velocity in miles per hour. So we learned that the formula V is equal to R omega. Okay, so I've given you the radius as 6 feet. We've got omega as 7.33 radians per second now. Okay, so I want to go ahead and do that. Then we're going to have to do a unit conversion on this. Now notice I wanted the answer in miles per hour. So we can go ahead and do this in one step if we want to, like this. So if we want feet to go away, we know that there's 5,280 feet that make up 1 mile. Okay, so that will be a unit that crosses out. And then we want seconds to go away, and we want to convert that to hours. So we can do seconds on the numerator, hours in the denominator, and the connection is there are 60 seconds that make up 1 minute. Okay, so if we do that now, we're in minutes. Now we need to convert the minutes to hours. So I put the minutes in top. I put the hours in bottom, so we know that there's 60 minutes that make up 1 hour, like this. So what we're going to need to do is we're going to need to multiply out. You can see how the units go. Now we ended up, after we crossed everything up, we have a miles, and then we have an hour. And again, all these units crossed out the way they were supposed to. Okay. So now what I need to do is I need to just take the calculator and crunch it out. So I'm going to slide this over the side so you can see what I'm doing. So what I'm going to do is just take 6 times 7.33 times 60 times 60. That's just going straight across. So that'll give that amount. And then the denominator, you've got 5,280. So we're going to take that and divide that by 5280. And that should give us the answer. So it's about 30. We'll just round that off to 30. So the final answer to that would be 30 miles per hour. Okay, so that's a pretty good problem. I've given you the angular velocity. So notice kind of what I gave you is I gave you the angular velocity. I gave you the radius. And then we used this formula, V is equal to R omega. Okay, we're going down to number 5 next. Okay, number 5, we're finding the area of the sector. So the area of the sector formula is area equals 1/2 r squared theta. And again, theta must be in radians. If it's not in radians, then you're not going to get a sensible answer. So the first thing that you want to do is you want to take the 35 degrees and convert that to radians by multiplying by pi over 180. So that's going to be 35 pi over 180, like that. And then you could just take that on a calculator since you're going to get a decimal approximation anyway. So we can just go 35 times pi, divide by 180, and I'll round that off to, let's say 4 decimals, so let's say 0.6109. Okay, all right, so we got that worked out, 0.6109. Okay, now we're just going to plug everything into this formula. So the area is going to be 1/2. The radius was given as 10 feet. So that's going to go in there, and then we're going to square that. Then the angle, we had to change that to radians. So it's going to be 0.6109, like that. Now we just work out the details. So we're going to have 1/2 times 100 square feet times 0.6109, and then the answer of this is going to be in square feet. Okay, so you can do this in the calculator like this if you want to. There's actually several ways you could do this. So you could use 0.5, or you could just go like parentheses 1 divided by 2. Okay, and then times 100, and then times 0.6109. Okay, like that. So that'll give about 30.55. The problem said round to 2 decimal places, so that's 30.55. Okay, so we get 30.55 square feet on that. So the key thing on that one is again, if I'm asking for some problem about area of a sector, now that's a formula that you're going to be given, so you don't have to memorize that. Just got to know how to use it, and the key thing is theta must be in radians, so you don't want to forget that. Okay, moving on to this next page here. I'm going to look a little bit at this problem. So one thing I want you guys to be able to do is an application of a right triangle. So first of all, this says that you have a man who is 6 feet tall. So I'm going to make a little note there that this guy is 6 feet tall. Okay. Then it says he is standing 30 feet from the base of the pole. So that means that part right there is going to be 30 feet. Okay. And ultimately we want to find the height of the flagpole. So we're looking at this whole piece right there. I'll call that H. So what we have is we have a right triangle. And if we look at this right triangle, I'm going to just sort of look at this part of the right triangle right here. All right, and the only other thing that you were given on this is it did give you angle of elevation. So the angle of elevation from his eye all the way to the top of the flag is going to be given as 23 degrees, 16 minutes. So see, what we can do is we could find this side of this triangle right here. So what I'm going to do is I'm going to call this little piece right here X. So if you talk out what we have, see, we have an angle, we have a side opposite, which is X, then we have a side adjacent, which is 30. So the side opposite over adjacent is the tangent. So what we could say is the tangent of 23 degrees, 16 minutes, by definition, is equal to the opposite, which is X, over 30. Okay, like that. So when we do that, then we've now got a proportion that we could go through and solve, and we can solve this by cross multiplying. So we get 1 times X is X, then we get 30 times the tangent of 23 degrees, 16 minutes, like that. Okay, now we're just going to go to the calculator and crunch that out. So I'm going to display the calculator over at the side here. All right, so what I'm going to have is, first thing is you're dealing with degrees, so you want to make sure that you're in degree mode, like I am. Okay, then clear this off and just go 30, then go tangent, and then 23. The best way to do that is just plus 16 out of 60, like that. Okay, and then just round that off. So that's going to be about 12.9 feet is what you get there. So I'm going to record that as 12.9 feet. Okay, so what we have then in this, to kind of put this all together, is this part of the triangle right here, from there to there is 12.9. Okay, and then the guy is 6 foot tall. So if we just add those two things together, we'll get the final answer. So we just take 12.9 feet plus the 6 foot tall that the guy is, and that's going to give an answer of 18.9 feet. Now that's one way to do the problem. There's, another way I could think to do that problem, but that's a pretty logical approach. Okay, so that'll wrap up those problems, and then you can study over this and see if this helps you to prepare for these kind of problems.